Okay, come, let's take a look at 4a. Now, instead of expanding the whole thing, we just need to expand a little bit. Okay, or we just need to look for a specific term in the expansion. So the use of the binomial theorem or the formula, right, is that this formula, the r plus 1 term, okay, is going to be equals to, okay, n choose r, a to the power of n minus r, b to the power of r. Okay, so this is the theorem or this is the formula. Okay, so we are looking for the sixth term, right? We are looking for the sixth term. So if you are looking for the sixth term, this is actually r plus 1 equals to 6. We are looking for T6. Okay? We are looking for T6. So the r plus 1 is going to be equals to 6. So r is equals to 5. Okay? So when we expand, we are looking for 5. Okay? Then we will get the sixth term. Because the r starts from 0. 0, 1, 2, 3, 4, 5, and so on. So if you count, right, the number 6 term, the r is going to be 5. Okay, so let's start this. So we just straight away T6. T6, but you bear in mind this is r equals to 5. Okay, T6. So this is going to be equals to n choose r, a, and a b, correct? So n is 10. We have our a, we have our b over here. So r is 5, so I'm going to put 5 here. This one is n minus r. This is going to be r, like that. Okay, then we just use calculator lor. So in front, what is the value? Straight away. What does your calculator say? So the front part, just use calculator. Oh wait, actually no need first. Let us do something neat first. Okay, we have 10 choose 5. We have 2 to the power of 5. Let's take the negative 1/4 out. So negative 1 over 4 power 5. We have the x5 over here. Okay, this whole thing, let's use calculator. Okay, so we have 10 choose 5, 10c5 on your calculator. 2 to the power of 5, which is 32, times 1 over 4. Negative 1 over 4 to the power of 5. Okay, so this is negative 63 over 8x to the power of 5. So this is the sixth term. Okay? So far so good? So far can? Okay, for part B. For part B, we have another one. We have x minus 2 over x to the power of 12. Okay, and we are looking for the term independent of x. Okay, we are looking for the term independent of x. So unlike the part A where they tell you a specific term, we will just use the r to find. For this one, we need to do a bit more work because we don't know which term is independent of x. Okay, so which term is it? We are not sure, so we need to use the general term. So the general term, tr plus 1, okay, is going to be equals to n choose r, a to the power of n minus r, and b to the power of r. So it's just applying the formula over there. Now the r is the unknown. Okay, our r over here, it is the unknown. Okay, so like before, all the coefficient one side, all the x one side. Treat it as a polynomial term. So coefficient is 12 choose r. Okay, so this is a number. This is going to be the x term, so I will put the x term somewhere behind. Okay, it's just rearranging the Lego. Okay, this one, negative 2. So negative 2 is a number, so I put a negative 2 to the power of r in front. Okay, and last but not least, this is 1 over x to the power of r. So all the numbers in front, all the x's at the back. Rearrange. Then let us do a little bit of laws of indices to simplify this. So we have 12 choose r, negative 2 to the power of r. This one, so this one is x to the power of 12 minus r minus r. Agree? Agree? Power 12 minus r. This is x to the power of negative r. So by law of indices, 12 minus r minus r. Can? Okay, if you want one more step, so 12 choose r, negative 2 to the power of r, x to the power of 12 minus 2r. Okay, so for the term independent of x, meaning the term does not have any x, what does it mean for this power? This term must be, the power must be 0. So for the term independent of x, okay, this power 12 minus 2r equals to 0. When you solve, r should be equals to 6. Okay, so therefore the term independent of x, which is t7, is equals to 12 choose 6 negative, or we can just use this one already, negative 2 to the power of 6 x to the power of 6, x to the power of 0. So this is just 59136. Okay? Something like this. Okay, so for term independent of x, we need to do a little bit more work. Okay, we need to do a little bit more work to find the r. Then we use the r and redo this step. Okay, so there's two choices. I use this because of easier subbing. In case you want to play safe, you can go back to the original one to sub in. Yeah. Yeah. Is 0, means there's no x in the term. So it's a constant term. Okay, so there are a few variations. Term independent of x. There is we call this the constant term as well. Okay, means there's no x, no variable term. No x. X power 0. Yeah, x power 0. So this whole thing will just be 1. Okay, so it is just this number itself. Yes. Okay, question 5. So now we have another one over here. So write down the general term of this expansion. So the general term, we make use of this formula. Okay, so it will be n choose r, something and something, correct? So we have 9 choose r, we have the 2x, we have 1 minus 1 over 4x squared negative. So let's take a look at the power. The power will be r. This is 9 minus r. This is r. And this is general term, so it's tr plus 1. The r plus 1 term. Okay, term number r plus 1. Okay, do you need to simplify? Most of the time, yes, you need to do a little bit of surgery. So let's do this. So we have a 9 choose r. This one, law of indices, 2 and x. So 2 power, x power. So 2 to the power of 9 minus r, x to the power of 9 minus r. Same thing over here. Let me get the negative 1 over 4 out. And let me get the 1 over x squared out. Okay, must split out nicely because they are a product of two things, r and r. Do you see how it works? The number, power r, the x term, power r. So we arrange, so 2 to the power of 9 minus r. I have a negative 1 over 4 to the power of r. Then I have an x to the power of 9 minus r and x to the power of negative 2r. This one over here. So all together, just copy paste x to the power of 9 minus 3r. Okay, so this is the general term. Okay, so the front part is just number. 9 choose something, one number, then x something. Okay. Then very interestingly, this one is in the multiple of, when you expand, right? The x's are in the powers of multiples of 3. Okay, 9 minus 3 times 9, so it's a power of 3. Okay, I say it's a multiple of 3. Okay, in case they ask, then yeah. Okay, part 2. Part 2 show that there's no constant term for this. So for this, okay, so now we need to show that there's no constant term for this expansion. So just now we've roughly expanded, or we've gotten the general term for this. It's just that this one we need to multiply in. So we need to find that there are no constant terms. Okay, meaning that there will always be x to the power of something. Okay, meaning the power of x cannot be 0. We need to show that. Okay, so let's try and do this. So this one will be equals to, okay, the general term tr plus 1 is going to be equals to this one in front. Cube is a cube. Okay, it will be this one in front. Okay, and it will be at the back, right? It is that thing all together. So this is 9 choose r, 2 to the power of 9 minus r, negative 1 over 4 to the power of r, and x to the power of 9 minus 3r. Okay, so it is the black part multiplied by the expansion, the general form over here. So this is one whole chunk. So this thing times 1, this thing times the second one. We need to do this. Okay, we'll need to do something like this. Okay, so let's do something like this. Let's expand. Okay, let me draw this slowly. Ayo, this one is, okay, this one will look like madness, but cannot be patient. So in front the number, okay, this one just copy paste, this one not so important. Okay, we are interested in this. Okay, let's expand the next term. We are interested in, wow, 16 times 16 over 3 times this. So 16 over 3 times 9 choose r times 2 to the power 9 minus r over 1 over 4 power r, and then x cubed. So this will be x to the power of 9 minus 3r times x cubed, like this. Okay, so this is the one where we are interested in. Okay, it's just expansion, so it's just expanding and just copy paste. Looks very ugly, but it's just copy paste. Okay, and even if you copy paste wrong, most of the time, because in replacement of speed, we mark very fast, right? We are only interested in this. So usually we don't have the eyesight to look. Even if you copy wrong, I think, yeah, but be careful, okay? Yeah, we are more interested in the x term because we want to show we want to show that it doesn't have a constant term. So we need to observe this. Okay, let's observe this and see. Okay, so for this one, for a constant term, okay, for a constant term, over here, do we need to do anything about this? Over here, 9 minus 3r is equals to 0. So r is equals to 3 for this one. Okay, then for this second term, for a constant term, okay, this one over here, 9 minus 3r plus 3 is equals to 0. So r is going to be equals to 4. So for this thing to be a constant term, r is equals to 3. For this thing to be a constant term, r equals to 4. So the thing is, right, like in order for, but the problem is when r equals to 3, this is the constant term, but they have an x term over here. Okay? And the next one is, if r equals to 4, this thing will be a constant term, but there's going to be an x term over there. You get what I mean? So this is only true for this one, but when r equals to 3, you will still get x to the power of something here. Okay, one more time. Then, if r equals to 4, this will be a constant term, but you still get x to the power of something over here. So what you do is, you can write law, you can just roughly explain however. Okay, so the conclusion, there are no okay, this is a very poor way of doing this, but yeah, I think should be correct. Yeah. No, there's no constant term in this expansion. So I'm trying to explain why is there no constant term in this expansion. Yeah. Okay, now, given that the constant term is twice the coefficient, okay, so they say that the constant term is equals to 2 times the coefficient of the x cubed term. Okay, so this is the relationship that we'll need to explore. But first, let us find the constant term, and then we'll look for the x cubed term. So in order to do that, we need two specific terms, right? We need a general form. So we'll need to look for the general form for the specific one. Okay? Can? So this is 9 choose r, a to the power of n minus r, b to the power of r. Okay? Let's tidy this up. 9 choose r, constants in front, so k to the power of r. Then I have x 18 minus 2r times x to the power of negative r. Okay? Then let's gather everything together. 9 choose r, k to the power of r, x to the power of 18 minus 3r. Okay? So this is the general form first. One, from here we need to do two things. So for the constant term, this power is equals to what? For the constant term, the power is equals to 0. So r is equals to 6. Okay, so let's find the coefficient of the constant term. Okay, so this is the x term, then it is the x part, this is the coefficient. So we are only focusing on this coefficient. Okay, so now let us form the equation to solve for k. So given that the constant term is equals to 2 times of the coefficient of x cubed term. Okay, so I'm just comparing the coefficient. Okay, so 9 choose something, k to the power of something is equals to 2 times of 9 choose something, k to the power of something. So for the constant term, r equals to 6. So I put the 6 over here. Okay, for the x cubed term, the r is equals to 5. So I'm going to put 5 over here. So it's just comparing coefficients. Okay, take the coefficient, make it equal, then we try to solve and see what magic we have. So 9 choose 6 is 84. So 84k power 6 is equals to 2 times 9 choose 5 is equals to 252k to the power of 5. Okay. Then let's solve this one. So 84k to the power of 6 minus 252k to the power of 5 equals to 0. 252 can divide by 84 or not? Can. So k to the power of 6 minus 3k power 5 is equals to 0. Okay, so let's factorize k power 5 out. Then I have a k minus 3 out over here. Okay, so now it becomes like quadratic equation, that kind of thing, or cubic equation. So k to the power of 5 is equals to 0. So k is equals to 0. Or k minus 3 equals to 0. K is equals to 3. So after doing this, right, let's check which one do we reject. Which one do we reject? The 0. Why? Because if k is 0, the entire thing is 0. So don't need to think, don't need to expand, correct? So a bit pointless. So we just reject this one. Reject 0 and we take 3 as our answer. Alright, so question 7, last one, second last one. So 2 minus 3x to the power of 10, we want to expand for the first 3 term. Basically, it is the general one repeated for the first 3 times. So let's expand. So we get n choose r, a to the power n minus 1, b to the power of that one, plus n choose r, a to the power of something, b to the power of something. Sorry, a bit more. Okay, plus n choose r, a to the power of something, b to the power of something. So let's fill in the power. We start with 0, 10 minus 0 and 0. This is 1, 10 minus 1 and 1. This is 2, 10 minus 2 and 2. So it's the same thing, copy paste. Okay, but you just change the r. Okay. So 10 power 0 is 1. 2 to the power of 10, okay, I'll just write 2 to the power of 10. This to the power of 0 is 1, so I leave it like this. Next one, 10 choose 1 is 1. 2 to the power of 9, so I leave it at 2 to the power of 9. Negative 3x, so I have a negative 3x over here. Okay, 10 choose 2 is... Jialat, calculator. Okay, 45. 2 to the power of 8. Negative 3 square and an x square. Okay, then we go ahead and get all these numbers. 2 to the power of 10 should be 1024. Okay, 10 times 2 to the power of 9 is going to be a humongous number. Times negative 3. So minus 15360x plus 45 times 2 to the power of 8 times 9. 103680x squared. Wow, this one can die one. Okay. So big. Okay, so first 3 terms. Okay, part B, part C. So part B and part C is the application of binomial theorem, or in which the people in the 1800s, how they calculate 1.97 to the power of 10. So this is how they do last time. Okay, so 1.97 to the power of 10. How did they do this? Okay, how did they do this? So the thing is that we need to use this. So the expansion, any question? Okay, the expansion is just repeat, rinse and repeat that one. Okay, but 1.97 to the power of 10, we need to refer back to this one over here. Right, same form. So 2 minus 3x, right, and 1.97. So what is a suitable value for x such that we get 1.97? What will be a suitable number for x? So meaning 2 minus 3x, I need to get 1.97, agree? If I were to swap around, 3x will be equals to 0.03, agree? Then 1x is equals to 0.01. So we need to sub this into the expression to get an approximate value. Okay? So we just need to substitute x equals to 0.01. Okay? Then 1.97 to the power of 10 is roughly equals to 1024 minus 15360 to the power times 0.01, and then plus 103680 times 0.01 square, right? And any higher power, 0.01 cube and so on, right, will be very insignificant already. So we just happy until here. Okay? So if you can, so last time the people know calculator, right? So it's just moving the decimal, move the decimal here and there. Okay? So, but we have calculator, right? So let's mental wellness. So let's treat our brain easier. Minus 15360 times 0.01. As in like, yeah, correct. So this question is outdated lah, but you need to know how to write the program. Yes, okay, so what we have is 880.768. Okay, 880.768. Okay, let's try. On your calculator, you try 1.97 to the power of 10. Your calculator, is it close? Quite close. It's less than 1% error. Correct? 0.5 off, right? So it's less than 1% error. Not bad, not bad. To get a calculation that close. Okay, so for part C, in the same way, using the part B to estimate, right? What is the value of 3.94 square to the power of 10? So how do we estimate this? It's just the same, right? Correct. So it's just 2 times 1.97, correct? This one, right? Correct? Then if you use laws of indices, so it will be, oh shoot. How? Yeah. Right? So I have a 2 to the power of 10 times 880 times 768. So and then we just estimate using our calculator to 2SF. Okay, so meaning like that. Roughly 900,000. Yeah? No, as in using the answer of part B. Yeah, using the answer of part B to do this. Okay? So last time people do weird things like this. Okay?